Hydraulic forging machines are indispensable tools in the manufacturing of shafts and crankshafts, components vital to industries such as automotive, aerospace, and heavy machinery. Their precision, power, and versatility make them ideal for producing high-quality components that meet the stringent demands of these sectors. This article delves into the significance of hydraulic forging machines in the production of shafts and crankshafts, highlighting their advantages, processes, and the specific figures that underscore their importance. Hydraulic forging machines utilize hydraulic pressure to shape and form metal workpieces into desired shapes, such as shafts and crankshafts. These machines exert immense force, typically ranging from 10,000 to 880,000 tons, to deform and mold the metal. The process involves heating the metal to a specific temperature to make it malleable, followed by the application of hydraulic pressure to form it into the desired shape. The precision and control offered by hydraulic forging machines are crucial for producing components with tight tolerances and superior mechanical properties. Compared to other forging methods like mechanical forging, hydraulic forging machines offer several advantages. These include greater flexibility. Hydraulic forging machines can handle a wider range of workpiece sizes and shapes. Improved control. Hydraulic pressure can be precisely controlled, allowing for finer adjustments during the forging process. Reduced tool wear. The softer nature of hydraulic pressure minimizes tool wear and extends tool life. Enhanced product quality. Hydraulic forging often results in components with better surface finishes and mechanical properties. By understanding the significance and advantages of hydraulic forging machines, manufacturers can make informed decisions about their equipment and processes, ensuring the production of high-quality shafts and crankshafts that meet the demanding requirements of modern industries. Hydraulic forging, a precision art. Hydraulic forging, a technique that employs hydraulic pressure to shape metal, has revolutionized the manufacturing industry. Its precision, versatility, and efficiency make it an indispensable tool for producing high-quality components, particularly shafts and crankshafts. The precision offered by hydraulic forging machines is unparalleled. They can control the forging process with exacting accuracy, ensuring that the final product meets the most stringent specifications. This is especially critical for components like shafts and crankshafts, where even minor deviations can lead to catastrophic failures. The uniform pressure applied by hydraulic machines results in a consistent grain flow within the metal, enhancing its strength and durability. Hydraulic forging machines are incredibly versatile, capable of handling a wide range of materials and complex shapes. This versatility is particularly valuable in the production of crankshafts, which often require intricate designs to meet specific performance requirements. Moreover, the controlled deformation process minimizes internal defects, such as voids and inclusions, that can compromise the integrity of the component. Beyond their precision and versatility, hydraulic forging machines are also highly energy efficient. They consume power only during the actual forging process, reducing operational costs and minimizing their environmental footprint. Shafts, essential components in various mechanical systems, require precise control over dimensions and material properties to ensure optimal performance. Hydraulic forging machines excel in producing shafts due to their ability to achieve tight tolerances, enhance material strength, and increase production rates. Crankshafts, the heart of internal combustion engines, demand even greater precision and complexity. Hydraulic forging machines are ideally suited for producing crankshafts, as they can accurately create intricate geometries, ensure exceptional strength and durability, and minimize defects. In conclusion, hydraulic forging has become a cornerstone of modern manufacturing, offering precision, versatility, efficiency, and environmental sustainability. Its ability to produce high-quality shafts and crankshafts is a testament to its technological advancement and its vital role in driving innovation across various industries. Hydraulic forging, the industrial backbone of critical components. Hydraulic forging machines have revolutionized the production of critical components, particularly crankshafts and shafts, across industries like automotive, aerospace, and wind energy. Their ability to produce parts at high rates and with exceptional precision is essential to meeting the ever-increasing demand for these components. Consider the automotive industry, where millions of crankshafts are produced annually. Hydraulic forging machines enable manufacturers to achieve production speeds of 10 to 20 parts per hour, significantly reducing manufacturing time and costs. For instance, a leading automotive manufacturer produces over 2 million crankshafts annually, each weighing approximately 20 kilograms and requiring a forging pressure of 50,000 tons. The hydraulic forging process ensures that defects are minimized, reducing rework and scrap, ultimately resulting in higher product quality and lower costs. Beyond automotive, hydraulic forging is also indispensable in industries like wind energy and aerospace. Wind turbine shafts, often massive and heavy, are produced with remarkable precision using hydraulic forging machines. These shafts must withstand extreme loads and stresses, and the forging process ensures that they have the necessary strength and durability. In the aerospace industry, hydraulic forging is used to produce high-strength shafts for jet engines, which require immense forging pressures to achieve the desired properties. These shafts must meet stringent requirements for strength-to-weight ratio to ensure optimal fuel efficiency and performance. The production of crankshafts and shafts is a complex and demanding process that requires cutting-edge technology, skilled craftsmanship, and a deep understanding of materials and manufacturing processes. Hydraulic forging machines have proven to be invaluable tools in meeting these challenges and delivering the high-quality components that are essential to modern industries.
A few final tweaks. It's our shaft in all its glory. Red hot and ripping. Holy honk. Look at those tires. That's how critical stanza? Oh man, I'm nervous. I am nervous. So leaves the first shaft.
The genesis of a colossal crankshaft lies in the crucible of closed die forging, where counterblow hammers sculpt metal spindles into enduring forms. This transformative process, akin to a blacksmith's artistry on an industrial scale, yields crankshafts spanning 4.5 to 8 meters, each a testament to the raw power of metallurgy. Precision is paramount at this stage, as CAD/CAM technology meticulously shapes the dies, ensuring that every contour and curve aligns with the exacting demands of the final product. Post-forging, the crankshaft undergoes a rigorous regimen of heat treatments and surface finishes. Induction hardening and stroke peening infuse the metal with strength and resilience, while shot peening introduces compressive stresses to enhance fatigue resistance. These treatments prepare the crankshaft for the arduous tasks it will face, enduring the relentless forces of engine operation. To ensure the integrity of the component, non-destructive testing is employed. Ultrasonic testing and magnetic particle inspection scrutinize the crankshaft for internal and surface defects, leaving no stone unturned in the quest for perfection. Only those that pass this rigorous examination proceed to the next stages. Dynamic balancing is a critical step in ensuring smooth engine operation. The crankshaft is meticulously balanced to minimize vibrations, enhancing both performance and longevity. Final inspections are conducted with exacting precision, measuring tolerances to thousandths of a millimeter. This attention to detail guarantees that each crankshaft meets the stringent standards of leading engine manufacturers. Before delivery, the crankshaft undergoes a thorough cleansing and preservation process in a controlled environment. This meticulous care ensures that the component arrives at the customer's facility in pristine condition, ready for immediate installation. The horizontal turnmill center, a sophisticated machine tool, is ideally suited for the machining of complex parts like crankshafts. Its versatility and precision make it a valuable asset for automotive OEMs, tier suppliers, and manufacturers of various sizes. The VDF Series offers a wide range of applications, catering to shafts and chuck parts across industries such as automotive, rolling stock, and pump manufacturing. Constructed with polymer concrete and high-quality linear roller guides, the VDF Series machines are engineered to withstand the demands of high-precision machining. The robust design ensures exceptional stability and damping, essential for maintaining accuracy during complex and simultaneous operations. This unwavering performance is a testament to the meticulous craftsmanship that goes into every VDF machine. Revolutionizing crankshaft machining, the VDF Series. The VDF Series is a groundbreaking machine that has redefined the landscape of crankshaft machining. By seamlessly integrating turning, milling, drilling, and superfinishing into a single platform, it offers unparalleled efficiency and precision. This holistic approach eliminates the need for multiple setups and transfers, significantly reducing cycle times and boosting production output. Equipped with powerful main drives, the VDF Series delivers exceptional cutting performance, effortlessly handling both heavy-duty cutting and high-precision finishing tasks. With its versatile design, accommodating crankshafts ranging from 850 to 4,500 mm in length and 290 to 650 mm in diameter, it caters to a wide spectrum of production requirements, from large-scale series to smaller quantities. The machine's flexibility is further enhanced by its ability to adapt to various machining needs, from heavy-duty cutting to hard and soft machining. This versatility makes it suitable for diverse production environments, ensuring optimal performance across different scales and applications. To meet specific production demands, the VDF Series can be customized with additional features such as high-pressure cooling, minimum lubrication, dry machining, and tangential or lead-free turning. These options empower manufacturers to tailor the machining process to their unique requirements, maximizing efficiency and product quality. Beyond its technical capabilities, the VDF Series is designed with productivity and cost-effectiveness in mind. Its innovative design minimizes part costs while ensuring high reliability and availability. The machine's ease of service and excellent maintainability further contribute to its cost-effective nature, making it an ideal choice for high-volume crankshaft production. By consolidating multiple machining processes into a single machine, the VDF Series reduces the need for additional equipment and minimizes setup times, leading to substantial cost savings. This, combined with its ability to produce forged steel crankshafts, the critical components of heavy-duty engines, makes the VDF Series a valuable asset for manufacturers seeking to optimize their production processes. The forging of a titan, crafting the crankshaft's heart. From the crucible of creation to the beating heart of a machine, the crankshaft's journey is a testament to both human ingenuity and technological prowess. Born from a meticulously chosen steel, its molecular structure is a canvas awaiting transformation. Under the intense heat and pressure of industrial forges, the metal is sculpted into its nascent form, its grain structure refined to imbue it with the strength and resilience necessary to withstand the relentless forces of an engine. A ballet of precision engineering follows, as the crankshaft is shaped, polished, and compressed to exacting tolerances. The massive screw press, a titan in its own right, exerts an incredible force, compressing the steel to its desired dimensions and ensuring it meets the stringent demands of heavy-duty applications. With meticulous care, the crankshaft is trimmed, calibrated, and straightened, its alignment perfected to micron-level accuracy. A controlled cooling process stabilizes its structure, preventing warping and ensuring dimensional integrity. Finally, the crankshaft emerges, a masterpiece of engineering, ready to become the beating heart of a powerful machine. Beyond the machines lies a partnership between human expertise and advanced manufacturing systems. These systems, designed for flexibility and efficiency, handle the entire process chain, from raw material to finished product. Each crankshaft, a testament to this collaboration, is a marvel of modern engineering, a symbol of both human ingenuity and technological advancement.